All right, welcome to today's Explainer. We're jumping right in today because we've got a seriously wild historical coincidence to unpack. It turns out that July 1st is secretly one of the absolute greatest dates in the entire history of mathematics. I know, history usually feels like this giant random sequence of events, right? But every once in a while, the calendar aligns in a way that's just, well, it's just too fascinating to ignore.
Across completely different centuries and in entirely different countries, a handful of utterly brilliant minds all happened to share this exact same date. And the discoveries they made? We're not talking about dusty, boring equations you'd fall asleep reading in a textbook. These are literally the hidden engines running the modern world. Seriously, every single time you pick up a smart device or step into a modern building, you are interacting with the legacy of July 1st.
So, to figure out how this all connects, we're going to follow the structure outlined in our source document, titled ENGV, and use this timeline to track them down one by one. Think of this like a historical detective story. We're taking the clues left behind centuries ago to unlock the technology sitting in your pocket right now. By connecting these dots, we'll see exactly how highly abstract math transformed into our everyday reality.
Okay, think about this for a second. Have you ever actually wondered what makes the logic inside your smartphone or your calculator tick? We take it completely for granted today, just swiping and tapping away. But how on earth can a tiny device, literally no bigger than a deck of cards, process millions of flawless logical steps in a single second without even breaking a sweat?
Well, the answer actually takes us all the way back to Germany. The date, July 1, 1646, which marks the birth of Gottfried Leibniz. Leibniz was a true visionary. Not only did he give us the modern language and notation of calculus, the exact same stuff mathematicians still use today, by the way, but he actually went and built one of the world's very first mechanical calculating machines. He was one of the first people to realize that complex abstract math could literally be translated into physical, mechanical logic. Long before electricity powered our devices, this guy proved that machine computation was totally possible.
Leibniz fundamentally believed that understanding the true source of an invention was deeply important. And by proving that calculation could be mechanized using moving parts, he took the very first literal steps toward the digital logic that sits in your pocket today. His mechanical steps paved the way for our modern microchips.
So, that is our first major clue on the board. Let's move forward on our timeline and see how this builds. We are still on July 1st, obviously, but we're going to jump ahead exactly 1 century to solve another everyday mystery. We're trading the intricate mechanics of calculation for the vast, open ocean.
We use this tech absolutely every single day, right? Whether we're driving to a new restaurant or tracking a pizza delivery. But how does your phone's GPS actually know your exact coordinates? Even if you're stranded out in the middle of the ocean without a single landmark in sight, how do invisible signals pinpoint you on a spinning globe?
For that one, we can thank William Jones. And his connection to our golden date? He passed away on July 1, 1749. Now, back in the 1700s, getting lost at sea wasn't just, a minor inconvenience. It was a fatal problem. Jones applied rigorous mathematics to maritime navigation. He created these incredibly complex methods to calculate a ship's exact position using nothing but the stars in the horizon. He essentially brought mathematical precision to a totally unpredictable world.
He laid the exact mathematical groundwork for spatial positioning. So, quite literally, the centuries-old math designed to map the dangerous open oceans is the exact same foundational logic that guides your phone's map app today. Navigating by the stars is what eventually paved the way for navigating by satellites. Pretty wild, right?
Let's keep tracking our next brilliant mind. We're still on July 1st, but now we are zooming way forward to the 20th century. We're hopping over to the USA for an even bigger idea. At this point in history, the world is getting faster, and the problems are getting a lot more complex.
So, think about modern networks for a moment. When you run an internet search, how do data algorithms instantly sift through mountains of information and make the absolute best choice out of millions of options in just a fraction of a second? How do machines basically know what we want before we even finish typing?
That question brings us to July 1, 1923, the birth date of Herman Chernoff. He tackled this massive challenge by pioneering something called sequential analysis and optimal design. To put it in simple terms, he figured out the complex statistics of evaluating risks and bounds on the fly. He essentially created the core mathematical strategy that allows computational systems to constantly weigh probabilities and make quick, incredibly reliable decisions. By establishing strict rules for sequential experimentation, Chernoff wasn't just solving abstract math equations on a blackboard somewhere.
He was effectively teaching machines how to navigate uncertainty, how to evaluate risks in real time, and how to consistently make the optimal choice. It is literally the brain power behind your search bar.
One incredible date, so many distinct stories shaping our reality. Let's push our timeline to its final stop in this explainer. Because, okay, we've conquered computing, navigation, and data, but what about the actual physical world around us?
Have you ever looked at a massive modern architectural dome, or maybe the sleek frame of a futuristic car, and wondered, how on earth do they manage to be so physically light yet so incredibly strong? I mean, it kind of seems to defy physics, doesn't it?
Meet visionary architect R. Buckminster Fuller. And you guessed it, he passed away on July 1, 1983. Fuller engineered the future using what he called synergetic geometry. He realized that nature builds using specific geometric patterns that naturally distribute stress. By mimicking these exact mathematical patterns, he showed that we could build highly efficient structures that do way more with far fewer materials. He completely revolutionized how we construct our world.
Fuller actually viewed all of humanity as passengers on what he famously called Spaceship Earth. And to him, using synergetic geometry wasn't just about designing cool futuristic architecture. It was about engineering a better, way more sustainable world for all of us to live in. It was, at its core, about survival through mathematics.
So take a look at this timeline now. Every single person we've met today, spanning across entirely different centuries, crossing borders, working in completely different fields, they are all permanently linked by this single date, July 1st. And they were all driven by one shared underlying mission.
They all looked at the pure chaos of the world and asked the exact same question: what is the pattern hiding inside? Leibniz found the foundational logic for computing. Jones found the math for navigating the open seas. Chernoff found the statistics for making optimal choices. And Fuller found the geometry for advanced architecture. It's like four totally different pieces of the exact same magnificent puzzle.
Because these